This section is about compound inequalities, and we're going to be graphing them in order to understand how to write them in interval notation, which is, you're kind of interpreting what is this saying. Now we're starting out with compound inequalities that are ands, right? It's the and or is going to make a difference on how we interpret this. Notice it says solve, but we don't need to solve on this first example. So let's take a look at this. If I put this on the graph, x is less than or equal to 0, and x is greater than or equal to -2. Notice less than or equal to 0 is going to be this way. Greater than or equal to -2 is going to be this way, right, going to the right. And so I'm looking at, where do these intersect? Well, they intersect between the -2 and 0. So less than or equal to 0 and greater than or equal to -2 means my interval is from -2 to 0. Because once I go past this or this going in that direction, right, there's no intersection there. So I just name where it is between the two numbers. And -2 and 0 are both included because it's or equal to for both of these. We don't need to solve on this one either. We just need to figure out what's happening here with this. And so if we put this on the graph, all right, we're going to have greater than or equal to, make this nice and thick here, -4, and x is greater than 1. And so it's going here. So you can see that the intersection starts at the 1 or right past the 1, right? Because 1 is not included in this case. Greater than or equal to -4 and x is greater than 1. My interval then is from 1 to infinity. That's my solution set. Those numbers are solutions to both. Let's just think about this 2. 2 is greater than or equal to -4, and 2 is greater than 1. 3, same thing. So you can kind of pick some numbers in that interval and check. If I pick numbers between -4 and 1, then they only work for the -4 inequality, but they don't work for the one that's x is greater than 1. Okay, we do have to solve on these two. So we solve by subtracting 2. On this one, we have a couple of steps. Divide by 5 then. So we added 1. We're dividing by 5. So x is greater than or equal to 2. This is an and. Now notice on this one I said write the solutions in interval notation, and this is the same wording that's in your textbook and also on my lab. So you have to know, I better put this on a graph to figure this out. Okay, so x is greater than or equal to 1. Right, so that's going that direction. And my second one is x is greater than or equal to 2. Right, so we're going this direction. So you see that the intersection starts at 2, and my solution in interval notation, my solution set is 2 to infinity. And that's it. All right. On this next one, we're going to solve by dividing by -7. And then we reverse the inequality, right? It was less than or equal to, we're dividing by a negative, so greater than or equal to 3. And we add 20 on this one. X is less than or equal to +5. And we're still on and at this point. So we're going to use that to determine what happens on the graph. Don't try to figure this out without using a graph unless you're just really good, and then if you think you can do that, I guess that's fine. So greater than or equal to 3, we're going to go this direction, right? And then we're going to have less than or equal to 5, and we go this direction. Right, and where do my lines cross each other? Where do they intersect? Well, between the 3 and the 5. So my interval notation is from 3 to 5. Both the 3 and the 5 are included. And there's my solution set in interval notation. Okay. So on this next one, we have a compound inequality that's written a little bit differently. When it's written this way, this is an and, okay? And it's important to know that. So it says that 4 plus 2x is greater than or equal to -2, and 4 plus 2x is less than 7. So we're going to solve for x. So when we solve a compound inequality, we have to solve on all 3 of the parts here. So I'm isolating x in the middle, and that means I subtract the 4 on each side of the inequalities, if that makes sense, and that's why it's a 3-part inequality. It's sometimes these are called 3-part inequalities. So let's bring down what we have now. Right, and then we are going to divide everything by 2, right, all 3 parts. So we have -3 is less than or equal to x is less than 3/2. You possibly can hear my pug snoring, so if you hear the weird noises, that's what's going on. Now, this one's a little bit easier just because of the way it's written. We know that x is between -3, which is included, and 3/2. Let's go ahead and put it on the graph, though. All right, so we are at greater than or equal to -3. We are less than 3/2, and, right, so it's going to be what's in between these. I didn't draw very straight lines here. So my interval notation is from -3 to 3/2. The -3 is included, 3/2 is not included, and then that's it on that one. Okay, next, this is also an and because of how it's written, right? Because if it's written as a compound inequality with 3 parts, that is going to always be an and. Now, this one gets a little tricky because the numerator has a -2, but we'll work with that in just a minute. So first we need to clear the fraction, and that means we multiply everything times 3. So -12 is less than or equal to, that eliminates the 3, right? So that's just -2x plus 5 is less than or equal to 3. And then, of course, we solve the compound inequality. We subtract 5. So that's going to be -17 is less than or equal to -2x. And then -2. And then we divide everything by -2. Now, because of the dividing by -2, we have to switch the directions of our inequalities, which then causes this to be written basically backward, if that makes sense. And because 17/2 is 8.5, so the bigger number's over here on the left. So we basically kind of flip it over to the right, flip it sideways, and we're going to write it this way. 1 is less than or equal to x. It's less than or equal to 17/2. Really, you would read this from the middle. X is greater than or equal to 1, and x is less than or equal to 17/2. Because of how it's written, we know our interval goes from 1 to 17/2. And you can probably interpret this one without the graph because of the fact that it's written this way. And so that's it for that one. So now we're on some ORs. And so ORs are going to be a little bit different. With an OR, basically everything here is going to be included in the solution set. X is greater than or equal to -3, or X is less than or equal to -4. So let's put this on the graph and take a look at it. All right, so greater than or equal to -3 is going to be here, or less than or equal to -4. And because it's an or, it says this is happening or this is happening. And that means that we have to include all of this in our solution set, because the solutions are everything from -4 to negative, right? We're going to negative infinity and -3 to positive infinity. We write this as a union using interval notation. So my -4 portion is, you're basically writing an interval for each part, and then we have a union to combine those. Negative infinity to -4, union, this is the union symbol. -3 to infinity. Now this is not a U, it's a union symbol, but it looks a little bit like a U, so you may write it that way possibly. And that's how we take care of this one, is writing it with the union. Now, not every single one of these will have the union symbol. It will just depend on what we have for that particular interval. So let's take a look at this one. This one says that X is greater than or equal to -2. I'm going to draw it like this, or X is, let me find one that'll show up a little bit. Okay, X is less than or equal to 2. And this says or. It's greater than or equal to -2, or it's less than or equal to 2. Well, actually what happens here is that means everything on the graph is part of my solution set. So that means I have to say, okay, this is basically all real numbers. All real numbers in interval notation goes from negative infinity to positive infinity. And so here's another possibility for the types of answers you might find when you're graphing compound inequalities. All right, so I'm going to end this video at this point and then start another video to finish the lesson.